Alright, let's now solve some radical equations. Now in general, we want to get rid of the denominators. So let's multiply both sides by the same thing, which is going to be x minus 5, x plus 5. So if we do so, the left-hand side simply becomes the numerator, whereas the right-hand side becomes 5 times that denominator. So let's carry on here. Let's expand out this times this, which happens to be x squared minus 25. We're going to feed the dog, feed the cat. So we have 5x squared minus 125. Let's continue off by throwing everything to the right. So we have 5x squared plus x. Negative 125 minus 5 is minus 130. Okay, so now we're at the point where we have a nice quadratic, and we can simply punch in the quadratic into decimals and figure out that the answer is 5 or negative 5.2. Now, it's very important that you reject extraneous roots. We could use a quadratic formula to get this answer, but if you actually graph the original question, negative x plus 5 divided by this business here, looks like this, and y equals 5, which is the right-hand side, the only true solution is x equals negative 5.2. So we need to reject 5. Let's look at this quadratic. When we say that x equals 5, notice how here for this function, we have x minus 5. 5 minus 5 is 0, so we have a divide by 0 problem. So don't assume that the two solutions are always correct. That's the hardest thing in the senior math, is to reject extraneous, especially when the question doesn't give you any hints about them. Let's move on to question number 19. We want the denominators to be the same, so why don't we try making all the denominators the same? Let's multiply this by x. Let's multiply x top and bottom. Let's multiply this by x minus 2, x minus 2, and let's multiply the bottom by x minus 2, and the numerator, the top, x minus 2. Now let's multiply each part by this common denominator, x times x minus 2. So multiply by x minus 2, and the entire denominator blows up. You celebrate with fireworks. Boom! We now have a very simple expression. 2x plus 1 times anything is just itself, equals negative 1 times this becomes negative x minus 2. A much easier expression when there's no denominators. 2x plus x is 3x. Feed the dog, feed the cat. And let's throw everything to the left. So we have x squared, 3x minus 2x is plus x, and we have minus 2 equals 0. Let's try factoring. Let's try plus 2 minus 1. Looks good. So the potential answers are x equals negative 2 or 1. But again, we need to think very carefully. Are any of these roots extraneous? So we punched in this equation here, 2 over x minus 2 plus 1 over x, and then we have y equals negative 1. That's the right-hand side of the equal sign. And you can see that we have a very strange graph, but in fact there are two solutions, 1 and negative 2, which we solved by factoring. As for question 20, again we can make the denominators the same by multiplying by x plus 1 or x minus 4. But just for a bit of variety, let's try cross multiplying, just to show you some variety in the ways we can approach these problems. So x minus 4 times the cross, which is x minus 3, equals, we have 2x plus 1 multiplied by its cross, which is x plus 1. Let's expand these binomials. FOIL, first outside, inside last. We have x squared Negative 3x minus 4x is negative 7x. And then this times this is positive 12. We have 2x squared. We have 2x plus x is 3x. And 1 times 1 is just 1. Let's throw everything to the right. 2x squared minus x squared is x squared. 3x plus 7x is plus 10x. 1 minus 12 is negative 11 equals 0. And when we look at Desmos, we see this parabola here. Indeed, we can factor it, and you can see that the roots are negative 11 and 1. Now let's actually punch in the original question to see if any of these are extraneous. So here, when we punch in both rational expressions, you can see that there's actually 2 solutions, 1 and negative 11. There's no division by 0 problems, so both solutions are acceptable. It's your turn. What's the answer?